Today we're going to continue with our 3x3 system of equations. This is the worksheet entitled L5 for Lesson 5 System of 3x3 Linear Equations Worksheet 1. So question numbers 1 through 3 are asking us to decide whether the given ordered triple is a solution of the system, and we're just going to do numbers 1 and 3 of this group. So we have this triple solution 1, 1, 1. So we substitute, and this is going to be by hand. So we substitute 1 in for x, 1 in for y, and 1 for z. So we see in the first equation, yes, 1 plus 1 plus 1 does equal 3. 3 equals 3. That checks. Now in the second equation, 2 times 1 minus 1 plus 4 times 1. Does that equal 5? Well, 2 minus 1 plus 4 is 5. So that checks. And our third equation, 1 plus 4 times 1 minus 2 times 1, does that equal 3? 1 plus 4 is 5, minus 2 is 3. 3 equals 3. So the answer to 1, this is the yes. Going over to number 3, we have 2, 1, and 6. So we replace x with 2, y with 1, and z with 6. So in the first equation, 2 plus 1 minus 6. Does that equal negative 3? 3 minus 6 is negative 3. Yes, that checks. The second equation, let me change the color. 2 times 2 minus 1 plus 6, does that equal 9? That's 4 minus 1 is 3 plus 6 is 9. That checks. And the third equation, 4 times 2 plus 1 minus 6, does that equal 15? That's 8 plus 1 is 9. 9 subtract 6 is 3. 3 equals 15. That's a no. 3 doesn't equal 15, so no, this is not a solution to the 3x3 equation. Now for 4 through 7, we're back to solving. So we always start with, we label our equations A, B, and C. Decide on a variable to eliminate. I'm looking at the x's, y's. I would go with either the y's or the z's in this case. I'm going to go with z's. Okay, so I'm going to take A and negative C. So A and negative C. So A is x plus y plus z equals 6. And negative C, I'm going to negate each term here, which is the same as multiplying each term by negative 1. So that's negative 5x plus 3y minus 3z equals positive 10. I apologize, that should be a minus z. Okay, so now our z's are opposites. So now when we add, this is labeled D, negative 4x plus 4y is equal to 16. So we've used A and C, so now we have to bring in B. So I will go with B, and I'll do 4 times A. So B and 4A. Are there other variations I could do? Yes. So copying down B, I have 2x plus y minus 4z equals negative 15, and 4 times A is going to get us 4x plus 4y plus 4z equals 4 times 6 is 24. Adding these will result in E. 6x plus 5y is equal to 9. Okay, so now we're looking at D and E, and we choose a variable to eliminate. I'm going to go with the x's, so I'm going to, actually, I could go to 24x and negative 24x, but I could also go to 12x and negative 12x. So I like working with smaller numbers, so I'm going to do that. I'm going to go to 12x and negative 12x. So I'm going to take 2 times e. 2e gives me 12x plus 10y equals 18, and 3d. 3 times negative 4x is negative 12x, plus 12y equals 3 times 16 is 54. No, it's 48. Adding these, and we end up with a 22y is equal to 66. Oh, well, that's good. I feel a lot better. It's getting some large numbers here, but when we divide by 22, at least 22 divides into 66 evenly. So we have y is equal to 3. Now we go back to D or E. I'm going to go back to, I guess, E. Let's see. And replacing y with 3. 6x plus 5 times 3 equals 9. 6x plus 15 equals 9. Subtract 15. 6x is going to equal negative 6. And divide by 6, and you get x equals negative 1. And now going back to an original equation, I'll go back to A. We have x, which is negative 1, plus y, which is 3, plus z equals 6. So this is 2 plus z equals 6, so z is equal to 4, subtracting 2 from each side. So this is what I have as a triple, negative 1, 3, 4. Now before I circle that answer, I'll now go to the calculator, and I'll use the calculator to check. Right, so I'm taking negative 1 and storing for x, 3 storing for y, alpha 1, 4 store for z, enter, and now the equation, first one, x plus y plus z. Does that equal 6? Yes, it does. So that checks. I'm just going to say count, check. We've got 6 equals 6. Now the second equation, that was for equation A. For equation B, 2x plus y minus 4z. That does give us negative 15. That checks. And then for C, 5x minus 3y plus z. Remember, to get y and z, you have to use the green alpha key. Y is alpha 1 and z is alpha 2. Yep, negative 10. That checks. Okay, so then this is our correct answer. Next, number 5, and you are welcome to, pause the video and try it on your own if you like. Again, we start off with labeling our equations, A, B, and C, and determine a variable to eliminate. I could go with the y's, look pretty good. We already have a pair of opposites, or the z's. I'm going to go with the y's. We already have a pair of opposites there. So I'm going to take A and B are already opposites, so I'm eliminating the y's. Let's copy down A and B. And you'll see in this video I'm not showing every single step of solving. Okay, we add, this is our D, 7x minus z equals 11. We've already used A and B, so now we have to use C, and we're eliminating the y, so this has a 6y, and I will pair it with A and multiply A by 3, so that'll give me a negative 6y. Okay, so I'm taking C and 3A. I looked at B. My eyes wandered. Let's try this again. And now 3 times A. Adding these, we get E, 7x plus 7z equals 35. Well, this is nice. D is a positive 7x, E is a positive 7x, so let's just take one of these. I'll take D and multiply it by negative 1, and we'll eliminate the x's. I'm taking negative 1d, so that's negative 7x plus z equals negative 11, and combining that with E. So 8z is equal to 24, divide by 8, then z equals 3. Now we go back to D or E. I'll go back to D. 7x minus 3 equals 11. Add 3 to both sides. Divide by 7. And now go back to an original. Go back to A. X is 2 minus 2y plus z is 3 equals 7. That's negative 2y plus 5. Subtract 5 from 7 and we get 2, and divide by negative 2 and y equals negative 1. Now for the check, I'm going to pause the video, get everything into the calculator, and just show the check. Okay, so I have my values of 2, negative 1, and 3. And I've stored 2 for x, negative 1 for y, and 3 for z. Typed in the first equation, and press enter, and yes, it does check. So for our calc check, A came out to be 7, that checks. Now I'll just type in B, 6x plus 2y minus 2z is 4, that checks. And 4x plus 6y plus 4z is 14. So this is our answer, and we know it is correct because it checked. Okay, number 6, again, let's label A, B, and C. And choose a variable to eliminate. I will go with the y's. So I'll start with A and C because they are already opposites. D, 7x, y's drop out, plus 3z equals 3. And now we've used A and C, so now we have to use B. B has a negative 1y. I will actually take B and multiply it by 2 so that I have a negative 2y and add it to C. So I'm taking 2b, 2x minus 2y plus 6z equals 2, and pairing that up with C. The result we label E, 6x plus 5z equals 5. Now we have to take D and E, and looking at these two, we have to choose whether we want to eliminate the x's or the z's. Doesn't matter which one we choose, we're going to have to multiply each of our two equations. So I'm going to go with the z's. I'm going to make D a negative 15z and E a positive 15z. So that means negative 15z for D, so I'm going to take a negative 5 times D and 3 times E. Okay, so negative 5 times D, negative 35x minus 15z equals negative 15, and 3 times E. 18x plus 15z equals 15. Adding here, we get negative 17x with 0 equals 0. All right, divide by negative 17 and x equals 0. So x equals 0. Now we go back to D or E. I'll go back to D and put 0 in for x. 7 times 0 plus 3z equals 3. That's 0 plus 3z. So 3z equals 3. Divide by 3, z equals 1. And now back to an original to find our y value. We'll go back to C. 4 times 0 plus 2y minus 1 equals 3. That's 0 plus 2y. So this is 2y minus 1 equals 3. Add 1, 2y equals 4. Divide by 2, y equals 2. So we have 0, 2, 1. And now I'll pause the video and check with the calculator and just show you the check on the calculator. Okay, so I had stored in the values for x, y, and z and then typed in our equations. The first one came out to be 0, the second one 1, and the third one 3. So it checks. Now on to our last problem. Choose a variable to eliminate. I could go with the y's, these are already opposites. I could go with the x's. These are small numbers. Actually, I think I'm going to go with the x's in this case. I'm going to try the x's. A little bit of a change. Alright, so I'm just going to take b and multiply it by -1. So I'm going to use a and -1b. A and -1 times b. Let's move this up. There we go. So that'd be -x plus 2y minus 3z equals -6. And this is d is 5y minus z equals 7. So we used a and b, so now we have to use c. So I'll take c and -2 times a. -4y minus 5z equals -10. And this is e. So here we have d and e. We need to eliminate one of these variables, y or z. I'm going with z. I'm going to take d and multiply it by -5. So actually I'll leave e right here and take -5d gives me -20y plus 5z equals -35. And adding e and -5d, -24y is equal to -45. Something's not right here. You can tell it doesn't divide in evenly. So I have to stop and see if I can find my mistake. My mistake is here with this -20y. I must have been looking at the 4 instead of the 5. -5 times 5 is -25. And now we add, we get -29y, which this is not helping me at all. Okay, so now my second mistake is up here. -2 times a, -2 times 13 should be a -26. And then we add 3 and -26. That is -23. -23 and -35 is -58. And now, finally, when we divide by -29, yes, it divides in evenly. So y equals 2. Go back to D or E. I'll go back to D with a y value of 2. Solving for z. -z equals -3. Dividing by -1, z equals 3. Now go back to original. to be x minus 2 times 2 subtract 5 and x equals 1. So our triple order is 1, 2, 3. And they'll tell you that it does check.